Welcome to my channel Data Analytics and Artificial Intelligence News. Today I would like to show you how you can geocode customer data with SAP Datasphere as a source, with OpenStreetMap as a API service, and with Python. We will see how to consume data out of SAP Datasphere, and the data can have, for example, an SAP system as a source. After reading the data, we will use this data, customer data, with street or city and also country. Take this data, send it to OpenStreetMap, and we will receive the latitude and longitude data back. And then we will save this result again in the SAP Datasphere table that we can use it further, for example, within Excel or for geographical reporting or GIS reporting within SAC, for example. And this everything will be done via Python packages and codes, and we will went through it step by step. To do this, we need some tools already installed, but this will be also part of this tutorial and video. At first, let's start with the prerequisites. I have installed on my PC the Anaconda 3 tool, which includes the Jupyter Notebook, which we will use to do the Python coding. This is a great tool where you can code your Python, where you can test your Python, you can run line by line if you would like to do so, and you can also interact with it directly. On the one hand side, we need the SAP Datasphere as a source. And in addition, we need to have an internet connection to consume data from OpenStreetMap. Okay, let's start. At first, launch here the Jupyter Notebook and create a new notebook. With this, we get a new screen. We can select the kernel. This is new since version 7. I select it. Now let's format our notebook file a little bit. At first, let's do a definition for or description. Oh, let's use another one here. Let's call it Geocode customer data customers with SAP Datasphere plus OpenStreetMap plus Python. Okay. Then at first, what we need to do is we need to define variables. Let's use this section to make it more readable. And what we need is here, we need to also add libraries. Oh, let's rename it. At first, let's or include libraries. What we need here is, on the one hand side, we need the library for doing requests and handling JSON files. This is done via import requests, import JSON. Then to check our or to do a connection to SAP Datasphere, we need to include the library HDB, means HANA Database Client. This is installed via pip install hdbcli. But this is shown in another video of me. I will give you some links in the commentary section. Then you can check the other videos also how to install the libraries here. The other one is what we need for displaying and for handling the data is the pandas library, which gives us the possibility to handle or to deal with data frames. And furthermore, we would like to consume data out of the SAP Datasphere, and we would like to also write data back. To do the SQL statements, to do a creation, or to establish a connection, we need the SQL Alchemy library, which can be also installed via a pip install statement. SQL Alchemy, but this is also shown in my former video. Now we have all libraries installed which are needed. Let's run this and this should be finished fine. Yes. Let's do another section here or define another section. Define variables. We need them, or we need a lot of variables due to our connection we would like to establish. At first, we need to set the credentials for our database connection. That means we need to define the host, the port, and of course, we need to also define the database user and password. This one is also part of another video, the same video where I show you how to install the libraries which are needed to do to establish a connection. And of course, what we need to have further is we need to have defined the consumption schema and the database view. We would like to consume the data out of it. And of course, what we would like to do is we would like to write data back into the SAP Datasphere, and we need to store it. Therefore, we need to have an ingestion schema also defined, and the database table where we would like to integrate the data from the geocoding request. That means, in the one hand side, we would like to load data from the SAP Datasphere, send this data, the customer data with address, street, and country, to an API REST service from OpenStreetMap, consume the data, which is sent back from OpenStreetMap, and then we will save the data, that means latitude and longitude, into a specific table within SAP Datasphere. And this table is named table geo customer. This SQL Alchemy library is not really part of this video. We have two possibilities to consume and write data back. On the one hand side, we can use the hdbcli client to do really SQL statements, raw SQL statements. And here with this library, we can integrate the data via using data frames. But this should not be part of this video. Therefore, I will add another video to go into more detail regarding SQL Alchemy. But to have this available, let's use it. Now we defined all the variables. Please put in your host, your user, and your password, which can be found under the section for space management in the area of database user, where you have a small icon, an information icon where you can click on and get all the information. But please be aware that the password is shown only one time via creation. Okay, now we can start with doing the first step. That means establish a connection to Datasphere. I prepared the code already. It's a small code where you see we use the hdbcli client with a connect. We need to assign the right variables, which we defined here. Database host, port, user, and password. The encryption needs to be set to true for the HANA Cloud, and the SSL validation certificate to false. If the connection could be established, we will print SAP Datasphere connected. After that, we create a cursor, which is needed to do the SQL statements in the next step. For me, the database host, port, user, and password is defined at the top with all the credentials. Please adjust it by your own here in this section, and also for this section you can rename it to DB host, and then you need to fill in your specific host. Let's try to do the first connection. You see, with this small command, the SAP Datasphere is connected. See, let's rename our Jupyter Notebook file. Now we have it renamed to a proper name here. Okay, after establishing connection, we can start consuming data out of the SAP Datasphere. To do this, I prepared a view already. That means I have three files: the customer file, the sales documents file, and the transactional data file. And I create a view on top of those where I do some joins. That means I join the sales documents with the customers, with the transactional data, and get a result view. The result view looks like this. I have a sales document, customer, sales district inside, the customer name, the number and the name, the street, the city, the country, the sales organization, and the value. Here you see that I have sales documents, the customer, for customers, Google, Amazon, Mercedes, Audi, with their names, with their streets, the city, and the country. And these customers, we would like to go to Geocode. That means we would like to have for the customer name, the street, the city, and the country, the latitude and longitude information, so that we can display it on a geographical map. To do this, we will go back to our Jupyter Notebook, and you know that we defined here a consumption schema and ingestion schema. Let's prepare the first part here with read data from SAP Datasphere. For that, I created an SQL command: select top 1000 entries from the consumption schema and the view. You can use the consumption schema to read data, and this view, the consumption schema is a test, and the database view is named realized sales. Let's then print the SQL command only for checking. with the next command, cursor-db execution, remember here we have the the cursor database assigned to the cursor of the hdbcli cursor, and with this we can do the execution of this SQL command. Now let's check what the outcome is. Let's add another command here, or further commands. Now we execute the SQL command via this execution. But what we would like to have also the information, or let's display the information or data what we get back from the system. With rows or fetch all, we assign all the data to the variable rows. With the next command, which we can execute, is we put the rows into a data frame object. You remember we also installed or import the pandas object to use data frames. And after that, let's check what the display or the outcome is of this commands here. Great. We saw, remember, here those data records, and they are looking the same here. Okay, now we have the basis for starting the request against OpenStreetMap. Okay, then let's include another section here. Call OpenStreetMap. The basis URL for that is this one. This one is the URL we can call to do the call against the OpenStreetMap service, and we will get the JSON file or JSON format back with the query of what we will define. Let's copy it out. Let's check what we can do with it. Okay, and let's check what we can find. Berlin, or how it could look like. We cannot integrate a space. We need to add a % and 20 for the space, and let's call the Bundestag in Berlin. Let's see what the outcome is. Here you see the result of this request. It's a government, it's right, there is a place, and of course we will find the latitude and longitude within this request. And this is what we would like to have and would like to get back for all those customers. That means in the request we will find under the Geocode result the latitude and longitude. Okay, and this seems to work. Let's then see what we can, how we can achieve it. We know we have the data frame available for customers, or of all the customers. What we also defined here is the table and geo on customer. Let's check with the tool dbeaver if we have this table already set up in our schema. Remember, the test is our ingestion schema, and under table we will find the right table which we would like to use for data integration. We have the customer number, the latitude and longitude with those properties. Table already existing. Okay, what we need to do is for our data frame here of all the customers, we need to do a loop. What we need to define is a search string. That means we would like to geocode the column 5 plus 6 plus 7 and send it to the street map URL. Remember, here this is the query string where we need to add the information the system, the OpenStreetMap service needs to give us the right information, latitude and longitude back. But also we cannot send a space. Therefore, I replace the space by percent and 20. Now we have the right URL in place. To do the request. Here, please remember, we have also added the library for requests. With this command, we do the request against this search URL and get the response. And you also see the show results geocode is what we need to extract. Therefore, we can use this command, response, that means the result. We replace this by an empty field, or we delete this because I would like to have only this result to do a JSON conversion. The same for the brackets. That means I will replace those ones and the brackets by space. After that, we can load the JSON into another object. After that, we have a JSON file format available. Let's see what the outcome is. No, we need to print it. Print here we see the result. This is the first one, the second one, the fourth, and the third and the fourth one. Looks great. Let's command this out. To have a unique key, remember we loop over the data frame for customers. Within the column 1, we have the customer name, the customer number 1, 2, 3, 4. This needs to be extracted to have this available to do the the statement for inserting. Let's do a short check here. If the result, the request result is not empty, otherwise we jump to the next data record. What we need to do now is, from the request, we need to extract the latitude and longitude information. You know we get the latitude and longitude information here. To do this, I defined two variables, the latitude and longitude information. And we have the customer number already assigned here. That means we have the customer number, the latitude and longitude information. And our table has 3 columns, the customer number, latitude and longitude. After that, we can do the insert statement. Insert SQL, this is the variable. Insert into the ingestion schema and database table. This is defined here. For the rows, for the columns customer number, latitude, longitude, the values customer number, latitude, and longitude. These are the variables within the SQL statement, and now we need to assign them here. Via this execution command, we use the insert SQL statement and assign the variables customer, latitude, longitude, which we defined here, to these values here, to this values here. In addition, to do not do a small break, I put in a time point sleep 0.5 seconds, that we do not requests too fast against this OpenStreetMap. Let's execute the request or the section here. Okay, time is not defined. Then we need to import another library on top. Import time at time library. Let's with the execution. No, the object should be available. Now the calls are done, and we can check it directly in the dbeaver tool if we have some data available. Let's refresh. Oh, great. You see, we have the data available. Now the first one is double because we did the first call and get the error for the time library. But we see the values are here and hopefully correct. Let's do a check here. Nearly the same part like this one here. We can copy this part out. Means we would like to get data not from the consumption schema. We would like to get the data now from the ingestion schema where we integrate the data for the geocode information. We print the SQL command, and then let's rename it a little bit here, geocode, and let's see what the result is. Here we are. We have now the values available for the customers with their geocode information. Now we have everything what we need to do the further setup. Remember, we have here the realized sales, the view for the sales. Let's get back and create a new graphical view. And you can, to access the database table, which is within this space, you can go to sources and see here the ingestion schema, which we created. And under this, we will find our table, which we created or which we filled with our statements. Oh. Customer geocodes. Import and deploy. Let's wait shortly until the deployment is done. Successfully done. Let's do a short check if we get the data. Great, we have the data available. Now let's deploy this graphical view. Customer geocodes view. Now let's put the view on front. Okay, now we have the view created, and here we see the view and the local table. Remember, this is our main view. And here is a new view. And now via drag and drop, we can drag it, drop it to the existing view. You see the system checks the name and the type and do an automatic assignment. Let's do a left outer join because we do not know if we have all the customers geocoded. This is 1 and here we have 0 or 1. Okay, let's do the deployment. Let's wait shortly until the deployment is done. Successfully done. Let's do a short preview. If we have all the customers geocoded now. Okay, here we have the 4 customers. And here we are. Oh, we did a small mistake here with the with this one. It could be. Let's use this one in that way that we get for all the customers the information. Please be careful with the cardinality. It could be that you get double values or some data values are not appearing furthermore if you would set this up in a wrong way. Okay, now we have the 4 customers with all the geocode information available. Great. And now we can start working with it while creating an SAC story on top of it, and of course show them then on the map. To use this within the map, we need to set this to analytical dataset. We need to expose it for consumption, and now we need to define, yes, of course, a measure that we would like to display in our story then. Now we need to deploy it again. We will be notified if the deployment is successfully done, and now we can start working with SAC. Okay, thank you for watching and stay tuned. And if you like this, subscribe my channel. Then it's great. Thank you.